For imaginary numbers, you have to know that the first 4, you can type in the calculator. I to the first is I to the second is -1, I to the third is -I, and I to the fourth is 1. You can still type in I to the fifth, but I believe after I to the fifth, it's not going to do it anymore. The calculator is going to give you some weird answer. So when you're simplifying, you always want to try to break up the power, like I to the 14th, into powers of 4, and then leave what you have left over. So I'm going to write this out over here. I to the 14th plus I to the 27th plus I to the 61st. So a multiple of 4 would be I to the 12th. And then I would still have another 2 i's left over from I to the 14th. I'm breaking up into a multiple of 4 as an exponent and then writing whatever I have left over. I to the 27th, I know 24 is a multiple of 4, so I to the 24th. And I'd still have 3 i's left over, so I to the 3rd. Plus 6 e's, multiple of 4, so I to the 60th power, but I still have 1 I left over, so I to the 1st. So any multiple of 4, since my pattern repeats, any multiple of 4 as an exponent is going to equal 1. So this is going to equal 1, this is going to equal 1, and that will equal 1. So I just end up with I to the 2nd plus I to the 3rd plus I. I to the 2nd I know is equal to -1. I to the 3rd is equal to -I, so plus a -I. And then I to the 1st is still just I. So if I have -1 plus -I plus I, -I plus I is going to cancel with each other, so I end up with -1 as my answer. If I want to do the product of 2 i's, as we did up here, when you multiply with the same base, you add your exponents. So I to the 9th times I to the 5th would give me I to the 14th. And actually, we just did it. I want to break it up into powers of 4. So I to the 12th times I to the 2nd. So I to the 12th is going to equal 1. Times I to the 2nd, I know, is -1. So 1 times -1 is going to give me -1 as an answer. They're not always -1. That just happened to be those 2 examples.